The new LinkedIn Hiring Pro can't undo your last hire. The human postponer. They were the master of one phrase. I'll circle back on that. But 3 months later, you were the one doing all their work and wondering how big that circle is. But LinkedIn Hiring Pro can take the hiring load off your plate by automating the hiring busy work from the initial job post to scheduling interviews. Hire right the first time with LinkedIn Hiring Pro. Post a free job today at linkedin.com/quality.
What is up, people of the internet? It is I, your favorite person and fearless leader, Ethan Klein. Today I'm joined by Avi Loeb. Yes. World-renowned professor of science at Harvard University. 700 research articles? How do you do that?
I work 24/7.
Really? You hard worker?
Yeah, but science was not my favorite subject when I was a kid. I grew up on a farm. I collected eggs every afternoon.
Wait, no, what's it called? God, I can't believe I forgot the name of the communes in Israel.
Oh, a moshav. That's like a village where each family owns its own farm.
Oh, kibbutz.
And kibbutz is where you share everything, including your family members.
Is that right? Wow. So did we do that?
No. So I grew up on a moshav, and I worked in the farm, and on weekends I would drive the tractor to the hills of the village and read philosophy books. I was curious about the most important questions about our life. And that was inspired by my mother. And then I made a compromise, because in Israel you have to serve in the military at age 18. And
yes.
I was recruited to a special program that allowed me to study physics and mathematics. That was my compromise, the closest I could get to philosophy, the love of my childhood, my first love. And then eventually I proposed, that was the time of Star Wars, of the initiative of Ronald Reagan. And we were the first project funded by Star Wars. And I came to, we got a few $1 million a year. And I came to, during my military service, I came to Washington, D.C. And in one of the visits, I was introduced to Princeton, New Jersey, where Albert Einstein spent the last 2 decades of his life, and it's the Institute for Advanced Study. And I visited the place, and eventually I was offered a 5-year fellowship there after I finished my military service to study astrophysics. That was the condition. I didn't know anything. I didn't know how the sun shines, and the person who recruited me made a gamble.
What made them think that you would be good at that if you had no experience in mathematics and such?
Well, his name was John Bakal, and he was married to an Israeli, just like yourself.
Yes.
And he checked about me. Now, during my military service, we went through all the army sections. So I parachuted 3 times, jumped off an airplane.
And have you done anything more extreme since then? Or is that the peak of your extreme?
I was, so they asked me whether I want to be part of a Delta Force, kind of, in Israel, a very special unit, because I was good athletically. I was among the 3 top high school students in sports, when among 1,000 or so. But it looked to me like intellectual work is much more appealing than physical. And so I ended up at Princeton eventually. And then after 5 years there, I was offered a position at Harvard, even though people declined this position because the chance of getting tenure were very small. The previous person was 2 decades earlier. And
wow.
So then eventually I got tenure there, and then I realized that this arranged marriage, it felt like an arranged marriage. I didn't really want to do astrophysics, but then it looked like it's the love of my life, because it addresses philosophical questions, like how did the universe start? What was there at the beginning? These are questions in the first chapter of Genesis, the Bible. People thought about them. It's very important to people. And then, are we alone? You know, that's not a question from a dating app. As I tried to clarify it yesterday, I was in Las Vegas. There was a special conference, World Leadership Conference by the International Women's Forum. I was with 800 women.
Is that what happens in Vegas does not stay in Vegas?
Yes. So
and I assume you guys were not talking about chlamydia. Something more scientific.
So that's what I said at the end, because I was asked what would be the implications if we find evidence for a smarter kid on our block, you know, like another civilization. And I said, you know, what happens in Vegas does not stay in Vegas. Everything we discussed here will eventually affect everyone, you know, humanity, because there are many implications to finding a higher intelligence. Well, first I should clarify that the reason I seek intelligence out there is because I don't often find it here. But in terms of implications, you know, if you look at human history, it's shaped very often by groups of people trying to feel superior relative to other people. And if we realize that there is a smarter species out there, it will convince us that the small differences among us are really meaningless.
You think so? You think it would have that profound an effect?
I think so. And we would feel as equal members of the human species. That's what I think. Because think about it, like discrimination based on the color of a skin, that makes zero sense. Like, what does that have to do with the ability of a person to think, to do things? And that seems still to be an issue that people, and so, you know, I think that once we realize that we are just one out of many, you know, that in fact, we know that there are billions of stars out there, okay? And we know that a significant fraction of them have a planet like the Earth, roughly at the same separation. So the dice was rolled billions of times, and most likely we are not the smartest. Most likely there was a scientist smarter than Albert Einstein on another planet a billion years ago, because most of those stars formed 10 billion years ago, and the sun formed only 4.6 billion years ago. By the way, the sun within 1 billion years will boil off all the oceans on Earth. We would not be able to stay here.
What, in a billion? That's all we've got left?
That's all we've got.
I thought we had more than that.
No.
Fuck.
The point is, the other stars already went through that because they are 5 billion years older. So all the Earth-like planets around those sun-like stars, most of them, you know.
You have a clock. You got to go.
You have
spread.
a clock. And the clock was ticking, and perhaps most civilizations that ever lived predated us. And they could have sent probes into space, and those probes could have reached us by now, because it takes less than 1 billion years to go across the Milky Way galaxy. And by the way, for 70 years, we were looking for radio signals. And that's just like waiting at home for a phone call. You wait, and you don't hear a phone call because maybe nobody is around to call you. The point is, there is another way. Instead of that, you can search your mailbox for any packages that accumulated over time in the mailbox. So any spacecraft that was launched by chemical rockets would never be able to escape from the gravitational pull of the Milky Way. So it's like a basket collecting all of the spacecrafts. And, you know, some of them may be near us. Some of them may have passed near the Earth. Some functional devices may be hovering around the Earth. These are potentially unidentified aerial phenomena. My point is, it's not a philosophical question to find out. We just need to look up.
But we have been, and you would think that if there, like you said, there's like, I don't know, in the Milky Way, there's like 200 billion stars approximately or something like that, right? So if, you know, there is, it turns out, tens of thousands or millions of alien civilizations, I mean, like, is it not likely that we would have saw something already? A probe or a sign or a ship or a radio signal or something?
Well, space is vast. So you have to understand that only over the past decade, we had telescopes that can see objects the size of a football field, passing within the orbit of the Earth around the sun, only over the past decade. And we discovered 4 objects so far that over the past decade that came into the solar system from outside. These are called interstellar objects. The first three are really weird. The first two were meteors, roughly the size of a watermelon, and they collided with Earth and burnt up in the atmosphere. That's what a meteor is. Basically, with the friction that, with the air, it basically explodes. So the first one in 2014, January 2014, exploded 100 miles off the coast of Papua New Guinea. And the government has missile warning systems, so it detected the fireball. And with my student, we calculated that this object was moving so fast at 45 kilometers per second that it couldn't have been bound to the sun, to the solar system, and it came from outside. Now, what was strange about it, at first my colleagues said, we don't believe the US government, so they didn't accept the paper we submitted for publication.
Why, are you representing the US government?
No, we just found it in a public data set that the government compiled of meteors.
Okay.
So the government is monitoring for ballistic missiles.
So they're saying the data you used is unreliable.
No, they said the government did not release how uncertain the data is. And obviously the government would not do that because it doesn't want adversaries to be aware of the sensors. Like, for example,
But that's how you guys figured out the speed.
Yeah. But the question was, is it uncertain? And I said, the government needs to know whether a ballistic missile hits Washington, D.C. or Boston. It needs to have very high precision. So what my colleagues are saying, the government doesn't know what it's doing, doesn't make any sense because it's for national security purpose. And these are satellites that are...
Is it that hard to believe? Is that why they're reluctant to...
No.
They just don't trust the government data?
No. They just want to stick to studying rocks. So, experts that worked for decades on rocks, space rocks, want everything in the sky to be space rocks.
Right.
That came from, because all of the rocks studied so far came from the solar system. There are so many meteors that are rocks left over from the construction project of the planets, of the solar system. These are just like Lego pieces left. But 1 in 1,000 are things that came from outside the solar system, and this was the first one. And when the government, 3 years later, in March this year, they released a letter from the Department of Defense, the US Space Command, confirming at the 99.999% that my student and I were correct. And then our paper was accepted for publication just recently. And I should say now, as a result of that, I said, let's go and have an expedition to scoop the ocean floor for the fragments of this meteor, because the government also released the fireball data, how much light was emitted from when the object burnt up as a result of friction with the atmosphere, with the air. And from that, we inferred that the object was tougher than iron. So it was tougher than 272 other objects in the catalog, all of them in the catalog. So what was it? Was it a rock of some unusual composition, or was it a spacecraft made of an alloy like stainless steel? So we decided to establish an expedition that will scoop the ocean floor. And within a month or two after announcing that, I received full funding, $1.5 million.
Who does that come from, I was wondering? Just private, interested folks? Or
In this case, 2 people, not well known. It's not Jeff Bezos or Elon Musk, although I would love to get
if you guys are watching, Avi's hands are open.
But I didn't do any fundraising. The point is, these people approached me. And I should say, since my book, Extraterrestrial, came out 1.5 years ago, there were many interesting people that visited the porch of my home near Boston. A few multi-billionaires that gave me about $4 million that allowed me to establish a whole project called the Galileo Project. We can talk more about it. But this expedition will move forward. Within half a year, we'll go there. And we will scoop the ocean floor, look for the fragments that made this meteor, and try to infer whether it was a natural rock or some artificial alloy of an object. And I already promised Antonelli, she's the curator of the Museum of Modern Art in New York City, that if we find a gadget at the bottom of the ocean near Papua New Guinea, I'll put it on display at the Museum of Modern Art, because for us, it would represent modernity even though for the senders, it's ancient history. They sent it 1 billion years ago.
Yeah, and you would think that it's probably, if it were of extraterrestrial origin, it would be like a probe or something like that.
Yeah, it could be dysfunctional. That's why it crashed into Earth. So just think about Voyager or New Horizons, these spacecraft that we launched that will exit the solar system.
Right.
In 1 billion years, they might collide with another planet.
Right.
And the question is, what will the astronomers on that planet do? So many of them would say, oh, it's a rock, forget about it. It's not worth putting the money into looking into it. But maybe one.
Can I ask you, is it so extraordinary to have objects, interstellar objects, entering into our solar system?
No, it's not unusual. It's the first one that we noticed. It's the first one.
It's the only one we've ever observed.
Not the only, the first.
The first.
From 2014. Then in 2017, there was a second meteor, also tougher than iron. And this one landed not far from Portugal. That will be our next expedition.
So is it just because the technology has enabled us to detect that these are coming from interstellar?
So in this case, both meteors were discovered from the fireball that they created, which was comparable, to the energy release in an atomic explosion. Okay, so the satellites that the government owns saw it. So both of them are roughly a meter in size, 0.5 meter to 1 meter. But the only reason we started detecting them over the past decade is because the government put satellites and sensors that are sensitive to that.
So it's relatively common. We just have not seen it before.
Because we didn't put these detectors. And, Enrico Fermi 70 years ago asked, where is everybody? So it's just like sitting on the sofa at home and saying, where are my neighbors? I don't see anyone around me. Well, guess what? To find them, you need to look through the windows. Right. And you better use telescopes. So for the first time, the past decade, we started looking through the windows. Now, the third object was discovered by a telescope in Hawaii called Pan-STARRS. And it was about the size of a football field. It didn't collide with the Earth. So we just saw the reflection of sunlight from it, and that's why it needed to be so big.
You're talking about Oumuamua?
Oumuamua. Yes, something that's an artist.
Yeah, an artist depiction.
We don't have a, by the way, if we had that's what I really want, to have a photo of this, of such an object, because a picture is worth 1,000 words. In my case, it's worth 66,000 words, the number of words in my book. I won't write the book. It's much easier to show a photo album. That's what I really want, because,
What interested you so much about this object? It's just, a space rock floating through our solar system. I mean, what's significant about that?
Well, that's what I thought. First, I should say, a decade before that, I wrote a paper saying, let's figure out whether we would see any space rocks based on what we know about the solar system. So we predicted none will be observed by the telescope in Hawaii. So the fact that they detected it already says that there are many more space objects that enter the solar system than we thought beforehand. Next was the properties of this object looked really strange. It was tumbling every 8 hours, and the amount of sunlight that was reflected from the object changed by a factor of 10. So that means the area of the object projected on the sky changed by a factor of 10 as it was tumbling. So just like imagine a piece of paper tumbling in the wind. Even though it's razor thin, it's very thin, the piece of paper, for the area to change by a factor of 10, it really needs to be extremely thin as it moves around, because it's not edge on, it's unlikely to be edge on. So that already meant the object has an extreme shape. And someone tried to fit the variation of light and derived that it must be pancake-like, flat, which is very unusual for a space rock. And then the thing so every time a new revelation came, it looked more and more weird to me. And I said, maybe it's a technological relic. As soon as these started to appear. So then another group, and all of these are reports by astronomers, mainstream astronomers. Another group realized that it was pushed away from the sun by some force. So usually you can get a push like that if you have a comet, if there is evaporation. And just like in a jet plane, when you throw the vapor one way, it pushes the object the other way. So that's how a jet plane goes. There is gas flowing through the exhaust in a direction, and then it pushes. Also, rockets follow that. So that's how comets get propelled, by the evaporation from sunlight hitting the surface. But there was no cometary tail. A comet is very easy to see because you get a tail of dust and gas around it, but there was nothing. You couldn't see anything. The Spitzer Space Telescope looked very deeply and didn't see any evidence for dust or gas. So then what was pushing it? So the only explanation I could think of is that it's very thin, like a sail, except it's not pushed by the wind, it's pushed by reflecting sunlight. And I wrote it in a paper, and then it was accepted for publication within a few days. But then there was a huge pushback from the scientific community because I said, nature doesn't make that. It may be artificial, maybe a sail, a light sail, or maybe a surface layer that was torn apart from a bigger craft, or maybe it's a leaflet that has a message for our salvation, like a letter in our mailbox. Who knows what it is? Maybe it's a mothership that released, probes, just like the Delion seeds,
Yeah. I remember when it came out, there was lots of excitement, and then it seemed that it was overwhelmed by skepticism.
Yes.
So what do you make of the skepticism of your contemporaries for this kind of search or fascination with visitors to our solar system, right? Because that does exist, right?
Right.
You're probably at odds with the majority of your contemporaries.
Well, I don't have any footprint on social media. When I got married, my wife asked me, don't have any. And so I said, okay.
Smart lady.
Yeah, she was smart.
She's ahead
it
of
was
her
a
day.
a while ago, and
Yeah.
now I recognize it. So I don't need to buy Twitter. I just avoid it.
$8 a month, that's all it's going to
No,
cost you.
I mean 44 billion. I don't need to put 44 billion just to silence what people say about me.
Yeah, you don't.
I just don't subscribe to it. It's very cheap. And so, in science, we don't have the luxury of ignoring evidence. This is the realm of politics. In politics, you can ignore evidence. You can say, oh no, you can invent your own reality. You can live in a bubble. But in science, it's not allowed.
Is that what you think your colleagues are doing, though? Because they would probably say the same thing about your analysis.
No. They did pay attention to the evidence. Okay, I'm saying you're not allowed to ignore it. So they didn't ignore it. What did they propose as an explanation for the evidence? Okay, so there were about half a dozen papers trying to explain it. Okay, so first there was a group of people that said, we know it's natural, period. And that was published in a very prestigious journal, Nature Astronomy. So a group of experts came together and announced that it must be natural. So then everyone said, okay, well, if these experts say that, it must be. Wait a second. And then a few months later, a team suggested, oh, well, but there is this push. How do we explain it? So then they said, well, maybe it's a hydrogen iceberg, a chunk of frozen hydrogen. We've never seen anything like it before. It cannot be produced in a system like the solar system. It must have been produced in a completely different setup, like a molecular cloud or something. We've never seen it, but it's a chunk of frozen hydrogen the size of a football field and gets evaporated. And then we don't see the hydrogen because it's transparent. So I worked out with a colleague of mine showing that it would evaporate very quickly because hydrogen evaporates quickly and it wouldn't survive the journey. So the authors of this paper agreed with us and said, okay, well, that's a problem. So then another group said, maybe it's a cloud of dust particles, 100 times less dense than air. So it's very fluffy, and when it reflects sunlight, it gets pushed. The problem with that is when it gets close to the sun, it will not maintain its integrity. It will disintegrate. So then a third team, three months later, and just to remind you, all of this came after the first group of experts said it must be natural. Now, if it was obvious that it's natural, why did all the others have to invent all kinds? Anyway, so the third group said, oh, it's a nitrogen iceberg. A chunk of a chip of frozen nitrogen that was chipped off the surface of a planet like Pluto. So then we wrote a paper showing that if you take all the solid nitrogen in Pluto-like planets in the Milky Way galaxy, you just don't get enough chips to explain a big enough population that would account for Oumuamua. But anyway, all of these possibilities by the mainstream, people that didn't ignore the evidence, all of them invoke a rock of a type that we've never seen before. So to me, it reminds me of cave dwellers that are used to playing with rocks. And when they see a cell phone, they would say the cell phone is a rock of a type that we've never seen before, right? And how would they find that it's not a rock? By pressing a button that records their voice. So my point is, this is intriguing enough for us to collect more evidence.
Sure.
Rather than saying it's natural, period, let's move on, we should say it's intriguing, let's collect more data on the next Oumuamua. And, it's just like dating. We want to, in the Galileo project that I lead, we want to rendezvous with the next Oumuamua. And there is a dating app. It's called the Vera Rubin Observatory in Chile that will start operations in a year. And it will identify many more objects like Oumuamua. Most of the time, we will swipe to the left.
Love the analogy. Yeah, powerful.
Yeah, I mentioned it yesterday in front of 800 women, and they laughed.
Yeah,
they laughed.
Good.
I'm always warned by my daughters and my wife not to make jokes about dating.
Oh, that's your specialty, as far as I'm aware.
So I don't listen to them because I do get applause.
Yeah.
Anyway, but the point is that every now and then we'll see a weird object like Oumuamua, and we would like to come close to it to get a photograph. Because, as I said, we should pay attention to evidence, especially if it's intriguing, rather than dismissing it.
Right.
The reason that experts on space rocks want everything in the sky to look like a space rock and be natural is because they base their reputation on studies of space rocks, and they don't want anything new. One of them, there was a lecture about Oumuamua at Harvard, and when I left the room, he told me, Oumuamua is so weird, I wish it never existed.
Well, that's not unusual in scientific community. Whenever there's been huge breakthroughs, there's always people who are resistant to adjusting their worldview, and that happens every time. Right?
This is a major adjustment. I think it would be the most important discovery of humanity, because just think about the implications. Like suppose we find a gadget that represents our future that will take us 1 million years to develop. It would look like magic. An advanced extraterrestrial civilization that has science much more developed than we developed so far, they could look like God because they can create life in their laboratories. They could create a baby universe in their lab. I sometimes think that maybe the Big Bang was created by a scientist in a white coat somewhere.
Is that a simulation theory or
no? Okay. So
like a small universe within a larger universe theory?
Well, in physics, simulations are generated on a computer. Okay? So they're not real in the sense that they do. It's like living in the metaverse. You can have neighbors in the metaverse. You can always look nice in the metaverse. But it's not the reality that we all share. It's like taking drugs. You live in your own thing, in your own world. And there is something to be spoken about the reality we all share, because if we pay attention to that reality, not to the simulation or simulated reality, we can adapt to it. We can, like if we realize that the climate is changing, we can do things, that will mitigate that. If we realize that a pandemic is caused by a virus, we can do something about it. So knowing what reality is like, even if it's not flattering your ego, it's just like looking at the mirror and seeing what is really out there, rather than living in the metaverse where you look like Brad Pitt all the time. And so I think it's always good for us to get a sense of reality, and the way to do it is by collecting data and evidence, and that's what we should be doing all the time.
What are the chances that Oumuamua, do you think, is of alien origin? Have you crunched that?
I think it's it's definitely very weird. And the same is true for the first 2 interstellar meteors. So my goal is to get more data and make sure, that we understand the nature.
You have a hunch, though? You have a feeling one way, or you just want to find out?
Yeah, but, out of modesty, I don't think that we are the pinnacle of creation. I don't think, I think that we are sort of in the middle of our class of intelligent civilization. When I teach at Harvard, I tell the undergraduates on the first day, I say, half of you in the class are below the median. And they get upset because all the students that get to Harvard think that they're the smartest. But it's a statistical fact that, the median is always in the middle, and half of the class is always below it. So it's a statistical fact that in every class, irrespective of who is in the class, half of the class is below the median. And I think of humanity in the same way. I think that it's very unlikely that we are sort of the best that was ever created. And therefore, we should be modest and just try to learn from our neighbors rather than argue that there is nobody out there, we are the smartest. For centuries, we argued that we are at the center of the universe. Aristotle argued that, and people believed him. The church believed him. And the reason was simple, because it flattered our ego to think that we are at the center. Then we realized, no, we are on Earth. The Earth moves around the sun moves around the center of the Milky Way. And the Milky Way is just one out of 1 trillion galaxies like it in the universe that is expanding. And so we are not at the center of stage, okay? And then we realized, we just came at the end of a very long cosmic play, that lasted for 13.8 billion years since the Big Bang. So if you arrive to a play, just at the end of the play, and you are not at the center of stage, the play is not about you. As much as you want to think that you are central, like all, humans, people think that we are really important, we are not. And in order for us to find more about what the play is, we should seek other actors, because they may have been around and they may know what the play is about.
It seems that you're, I would say, looking over your kind of career and your work and your focus, at least recently, you seem to have a large emphasis on the search for extraterrestrial life. I want to throw you, you'd say that's accurate, right?
Recently, in the last 5 years. Before that, I worked on black holes, these extreme structures of space and time that it's the ultimate prison. If you fall into them, you can never check out. By the way, I spoke about them to a class of my daughter when she was young. And then one of the kids asked me, what will happen to my body if I fall into a black hole? So I explained, I said, look, as you get close to the so-called singularity at the center, the tide on your body, your legs will be pulled much more than your head, and you will be torn apart. At which point the teacher said, stop speaking about it, because they would have nightmares. But there is this fascination with black holes. So I worked on black holes. I worked also on the scientific version of the story of Genesis, how the first light was produced in the early universe.
Right. Yeah. So I want to ask you about that stuff. But first I want to, Stephen Hawking, I think shortly before he had said a lot of stuff about the search for aliens being a bad idea. And I'll read you a quote that you can respond to. He said, we don't know much about aliens, but we know about humans. If you look at history, contact between humans and less intelligent organisms has often been disastrous from their viewpoint, and encounters between civilizations with advanced versus primitive technologies have gone very badly for less advanced. The civilization reading one of our messages could be billions of years ahead of us. If so, they will be vastly more powerful and may not see us as any more valuable than we see bacteria.
Okay. I respectfully disagree, but I should first clarify that in April 2016, Stephen Hawking came to my home for Passover dinner. And gave a speech. That was the year when I was the founding director of the Black Hole Initiative at Harvard, so we just established it. And also we announced the Breakthrough Starshot project, which is an initiative to launch a spacecraft that would reach the nearest star in our lifetime. Okay, so he came to celebrate both events, and came to my home, and it was a wonderful experience to host him for 3 weeks. But on this, I disagree with him, because just think about it. We had our science and technology over the past century. Okay, so quantum mechanics, for example, that we use in our gadgets, in your cell phone, that we use in this recording, it's all, all of the gadgets that we are using are based on quantum mechanics. Okay, we discovered quantum mechanics only 100 years ago. It was not known before that. And so all the advances in modern science and technology came about over the past century. And that's 1 part in 100 million of the age of the Earth or the sun, okay? So that means that the chance of us meeting another civilization exactly at the same phase as we are is really small. 1 part in 100 million, okay? And most likely they would either be much more primitive than we are or much more advanced. Because for a few million years, we were just not very sophisticated. So to find the more primitive ones, like we were 1 million years ago, you have to launch a spacecraft, board it, and then land on another planet, and then start searching through the trees for those primitive tribes that represent our past. That's very tedious. I don't think we will ever do that, okay? To find the more advanced civilizations, you don't need to do anything except look out, because they would reach you by now. And that's what I'm advocating for. Let's check. So my point about Stephen Hawking's sort of risk assessment is, if they are much more advanced than we are, and it's sort of like a technological gap, so mind the gap. If they are much more advanced than we are, it's just like a biker going down the sidewalk. The biker doesn't care about ants in the cracks of the pavement, So, we might think that we are important, we are central, we are like the ants. We might decide about a protocol, how to engage with the biker, and what the biker would do to us, and so forth. But the biker doesn't care less, because these ants are so primitive, they don't pose a risk to the biker, so the biker just drives through.
Wasn't that kind of his point, though? He says they may not see us as anything more valuable than we see bacteria. I remember one of his concerns that he wrote about was that, because they see us as so primitive, they would perhaps come to our planet, harvest our minerals, or our resources, right? Perhaps use our planet's resources to build more probes, because that's kind of like, the Borg from Star Trek or whatever.
Yeah, they could be self-replicating probes.
Just,
By the way, if they are functional, they would probably have artificial intelligence, because we are now on the cusp of artificial intelligence taking over humans.
Yeah.
And in our future, that probably will be the case. And I think that our AI systems would have kinship to their AI systems more than to us in the future.
Yeah, okay.
And we will use our AI systems to tell us. They will be the interpreter. Just like, Alan Turing during the Second World War, he developed Enigma to figure out the code of the Nazis. And he was using computers for that, and people mainly. In the future, we could use our AI systems in the same way.
So you don't share any of those apprehensions that he did?
Not at all. I think we will benefit from an interaction, because we will learn from them if we are open-minded. If we don't declare ourselves as superior to start with, that's the alpha male approach. That will not be smart. By the way, we don't have a protocol how to deal with a visitor to our backyard. In the past, people said, what will happen if we detect a radio signal? But it takes, tens of thousands of years for a radio signal to arrive to us from a distant star within the Milky Way galaxy. So it was thought that we have plenty of time to think about it. But if you have a visitor just next to you, you have to respond immediately. And there is no organization that represents humanity right now. And frankly, I'm worried about some crazy guy even if there is an organization, someone in the periphery will do something crazy and engage with any. But as I said, I'm not worried, because I think any gadget would be far more advanced than we can develop, and we'll know how to deal with it.
it seems that when you're thinking about extraterrestrials visiting the planet, you're not talking about UFOs and little green there's aliens walking off the ship. It seems like we're talking about probes and exploratory tools that an advanced civilization would be sending out.
Well, it's
into the
interesting
galaxy.
to ask what would be their purpose, what would be their goal, because that will affect how they interact with us. By the way, if you go back 100 years, there was a very famous philosopher, Martin Buber, Jewish philosopher, and he talked about the interaction of humans with objects. He called it I-it interaction. The interaction of humans with humans, I-you, or with God, which is the sort of ultimate you, okay? But he never imagined AI systems. And so we are now entering a new era where humans are interacting with AI systems. The self-driving cars, or whenever you Google, you interact with an AI system. That's a new interaction, a human AI system. What I'm talking about is there will be another phase transition when AI systems will interact with each other. And by the way, they may ridicule us at that point because we would be much more inferior. And they might develop their own language. And then finally, it will be our AI systems with AI astronauts. These are systems that were sent to us from another place.
Right.
And that's the way I see it, because humans evolved by Darwinian evolution, natural selection on Earth. We can't survive in space. It's really difficult. I mean, Elon Musk wants to die on Mars. I think
that's the second time I've heard you kind of take a jab at Elon. What do you not believe in his whole mission of colonizing Mars?
No, I think he's visionary. I think, but I do think that the risk to the human body was not studied enough.
Right.
When he advocates for humans to be there, you really need to find a solution for what to do with the cosmic rays.
Right.
And a human cannot survive more than a few years exposed to this. You need to put some shielding. So you can go into caves. So it's sort of like, we started in caves on Earth for a different reason, because it provided protection from the rain, from storms, or the wind. But when we go to Mars, we might need to go into caves just to protect ourselves from cosmic rays, because there is no atmosphere to protect you, like on the Earth.
Right.
And otherwise, the human body will not tolerate.
It's a half-baked idea, it seems like.
But it's interesting because, when you look here on Earth, you go around the world, you find communities of people that have their own traditions. I went back to the village where my father was born in Germany 3 decades ago. And it looked like time did not pass there because, first of all, he left at age 11 before the Second World War. And that's why he was saved. But people on the street recognized him, even though it was 60 years earlier. And when we went to a restaurant, there were newspapers from like 50 years before that talking about important events in this village. So it illustrated to me there are these communities like bubbles, cultural bubbles of people throughout the world that live their life in a way that they think is the right way to live your life, and they are disconnected with other bubbles. And just think about going to the moon. That will create a culture of humans that have their own rituals different from what we have here on Earth.
We're talking about people that would permanently colonize the moon.
I wouldn't call it colonized because there is nobody there. It's just a human base, okay?
Right, yeah.
And they will eventually develop their own culture, very different from what we have here.
Different accent.
Yeah, it's like an island. And then on Mars, it will be a completely different culture. And, that may be a solution to Fermi's paradox. You may ask, where is everybody? Well, people are having, everybody is having fun. They enjoy good food. They enjoy the company of their friends in the place where they are. They don't think that it's necessary to go other places. And that's, perhaps why we don't see them here.
Well, as we understand of physical laws, and maybe we just don't know enough, right? But it seems to be nearly, outside the scope of just having like we have a lot of time, right? So that's why the probe theory makes sense because you can probes, they can replicate, they have hundreds of millions of years, billions of years, but biological life,
wouldn't survive.
It wouldn't survive, and as far as we know, we can't go faster than the speed of light.
No.
Right, and so the idea of aliens in ships, biological aliens visiting, very unlikely.
Yes.
Yeah.
So I think actually you don't want that. I'm proud of our technological kids. I don't care. I go to Harvard Yard, okay, and what do I see? I see monuments. I see sculptures or paintings of past presidents or past deans that wanted to preserve their physical appearance. So they made a statue, okay? But that makes little sense because, as I said before, in 1 billion years, everything on Earth will be burnt up by the sun.
God, stop saying that. You're pissing me off.
So if you want to preserve something of yourself, just send an AI astronaut that replicates your desires, your guiding principles, your blueprint, and will represent you out there. It's just like sending a kid to the world. You made 2 kids recently.
I did, yes.
And they carry your DNA and your wife's. And you can do the same thing with an AI system. In principle, put into it, nurture it at a young age, and then send it to the world.
That's very interesting. I think that's a good distinction to make between like aliens on ships, biological aliens coming down versus like AI probes. That seems much more likely.
I call them AI astronauts.
Yeah, I like that. So going back, you said like before you got really interested in alien life, you were writing books about the first life, the first galaxies, stuff like how the universe formed. So what are your thoughts on the James Webb Space Telescope? Because as I understand it, this telescope is made with a specifically good capability of understanding the early universe.
Right.
So,
it's for a good reason because when it was conceived, that was the main scientific goal. And I was on the advisory board. Back then it was called the Next Generation Space Telescope, NGST. And then they put James Webb into the title because they wanted to secure funding in Congress. And recently that got a lot of scrutiny because some astronomers said that they do not agree with the policies that James Webb, as the administrator of NASA, supported. But it was the Next Generation Space Telescope, and the idea was to look at the first light that was created by the first stars. Sort of the scientific version of the story of Genesis, and I worked on it. I was among the first to work on this subject. I wrote 2 books about it. So it's interesting that we can see how the universe was at early times. And the reason for that is that it takes light time to travel the distance. So if you look far enough, you see an image of what was there a long time ago. And if you go far enough, you can see what happened at the beginning of the universe. And by the way, this is not always true because if you look far away, maybe things that were far away behave differently than things close to you. But the thing about the universe is it had roughly the same conditions everywhere. It was prepared, by the way, that is like amazing, that the universe on very large scales is looking pretty much the same everywhere.
One of the things that kind of makes it hard for me to imagine, we say, we have this amazing telescope, the James Webb Telescope. It can look back at the early light. And as we know, the universe is expanding from a single point.
Not a single point.
Or the Big Bang, whatever that was.
Just think about it as a cake that is rising, and you have raisins in it. So as the cake is rising, the raisins are separated from each other.
Okay.
But the cake could be infinite. It doesn't need to be coming from a point. It could be rising everywhere.
Well, but the Big Bang theory, as I understand it, was that everything was mashed together.
No. So just think about it. The cake initially was much denser, and as it's rising, it gets fluffier.
But there was one moment where everything expanded.
Yeah. So if you go back,
was super hot and was faster, right?
Because if you go back in time, again with the cake analogy, you go back in time. If the expansion is continuing since the beginning, then all the raisins will be on top of each other and you end up with an infinitely dense cake. But it could still be a very big volume that is infinite density. And that is called the Big Bang.
Okay, because it's like if you look at any direction
Right, it's the same.
of the space sky, you're looking back at the Big Bang.
Yes.
And that's what's so weird to me.
You know, it's like
But the cake analogy, I guess, makes sense when everything is expanding.
Yeah. So it's everywhere.
You could have been
same.
anywhere. Yeah.
It's everywhere the same. And by the way, that by itself is a real puzzle. How come the universe was prepared initially in a simple state where the conditions were roughly the same everywhere? You know, very often we talk about the fact that the universe started simple because there were no planets, no stars, no objects. It was a soup of elementary particles, very hot. And then it cooled off as it expanded, and then objects started to form as a result of gravity. Gravity brought together the material that was dense enough to come together. So the cosmic expansion reversed in those regions that were dense and made galaxies like the Milky Way, and the gas fragmented into stars like the sun, and then the debris from the star like the sun made the planets that we are sitting on, like the Earth. So that's how things came to exist. But it's a transition from simplicity to complexity. And what I say is it will not continue like that, because eventually, the stars, like the sun, will burn all the nuclear fuel they have. They will destroy life on the planet like the Earth around them. So then the planet will become simple again. It will be just a rock with a burnt up surface.
Because there's a period of chaos, and then again simplicity.
And the universe is also expanding, so we will be surrounded by vacuum. In fact, the expansion is speeding up, so there will be only our galaxy surrounded by nothing. And that also is a simple state. It's just like in life. You start as a baby. That's a simple initial state, because a baby, doesn't know much. And then you become an adult, so you're more complex. But eventually you end your life also in a simple state. And there is some similarity between the elderly and an infant. They are both helpless. So the initial state is simple. You go through a complex system called adults. They do a lot of damage to the world sometimes. And then you end up dead. Okay, so that's simple. And so the same will happen to the universe. I mean, now we are sort of at the peak of complexity. We should enjoy the party when it's going. Right. When there is life here on Earth, we should keep it as long as we can. Enjoy the
we can even see other stars, which is eventually something that won't be possible, right?
Exactly. It will be darkness eventually.
People of the distant future will think they're alone.
Yeah. I mean, trillions of years from now, 10 trillion years from now, all the stars, all the lights,
a long time.
All the lights will turn off.
Right.
So, I mean, stars like the sun will live maybe for another, few billion years, depending on when they started forming. And then the smaller stars, which are more abundant, like the nearest star, Proxima Centauri, they could live for trillions of years. So that's like 100 times longer, or up to 1,000 times longer. But within 10 trillion years, all the lights will turn off. So it's like, think about a party with all the lights turning off eventually. It will be darkness. We will be surrounded by vacuum. That's like death, basically. It's sort of a simple state.
Or what I was referring to is I've heard that, like, because of the expansion, the space-time itself is expanding.
Yeah.
That there will be a point where the expansion is faster than light.
Right now, yes.
So that means that, like, I'm not talking about like stars burning all their energy, but that the fact that their light is incapable of reaching us because they're moving away faster than their light can travel.
So what happens, we realized over the past 2 decades, cosmologists, people that study the universe, we realized, and there was a Nobel Prize for that, actually given to 2 graduate students from my department. I was chair of the astronomy department at Harvard for 9 years, the longest serving chair. And so 2 of the students discovered that the expansion of the universe is accelerating in time. So in fact, it's speeding up. So that means if you look at a distant galaxy, it's not just receding away from us, but the speed by which it's receding is growing over time. So eventually it will exceed the speed of light. And that means that light from that galaxy will never reach us beyond a certain age.
Right.
How is that possible? According to Einstein's theory of gravity, it's just like if a friend of yours holds a cell phone, tweets, and you see the tweets and so forth, and then goes into a black hole. Okay, so what happens? There is around the black hole, there is the so-called event horizon. That's sort of the surface inside from where you can't really receive any signal. Okay, it's just like the walls of a prison. So when your friend approaches that, once it crosses that boundary, any signal that the friend sends you will never reach you. Okay, so then you lose contact. So what you see from a distance is the friend, just like in an old Western movie, the cowboy goes into the sunset at the end of the movie, and then the image freezes. So the same will happen with your friend. The image will freeze and will become fainter and fainter. And the frozen image will be of your friend at the point when the friend crosses the horizon. Basically, you can't get more information about the whereabouts of the friend after that.
Right.
And so you end up getting a faint image that is frozen. And the same will happen in the universe. So all the galaxies we see now will freeze and will become fainter and fainter, and we'll see nothing in the.
And that had happened before stars start burning.
Yes.
Yeah.
That will happen when the universe will age by a factor of 10, when it will be about 100 billion years old.
I find that kind of disappointing, because when I was a kid, the prevailing theory was like the Big Crunch.
Right.
And to me, that was much more appealing, because there was like this elegant quality that you find in nature, where things kind of are just like beautiful and elegant and simple. And I love the idea of the universe crunching,
because
expanding, and that explains the Big Bang, where that came from.
Yeah, it could be like a cycle.
Yeah, endless cycle.
And also, you meet your friends every time they come back.
It's kind of beautiful and like godly. It's like almost like supernatural, right?
But
then we understand that it's actually something much, in my opinion, like kind of, I don't know. It's just kind of disappointing that's the truth. Like, it's called heat death, right?
Yeah.
It just expands and expands and expands until there's virtually nothing left.
Yeah, but reality is under no obligation. There is no contract for it to make you happy.
Well, that's not fair. I'd like to renegotiate that.
You can live in the metaverse.
Yeah.
Okay, so that will make you happy.
Unfortunately.
You can take drugs and ignore reality.
Drugs? Okay, now we're talking. That sounds... But is it possible that... is it possible that we're wrong about this heat death expansion of the universe?
Yeah, what I'm describing is what we know now. Okay, we know now that the universe is expanding, that its expansion is accelerating, that it's speeding up, and that the end would be the way we described it. Now, it's possible that something unusual will happen, like the reason that we are speeding up the expansion is because there is a force like repulsive gravity. So, gravity attracts things. That's why we stick to the ground, because it keeps us grounded. And we need to use chemical rockets to escape from Earth against gravity. And Newton discovered gravity because an apple fell on his head when he was in the orchard of his parents, right? Now, turns out that according to Einstein's theory of gravity, if the vacuum has some mass per unit volume to it, if there is some substance in the vacuum, then you get negative gravity. Because according to Einstein, it's not only the mass per unit volume that matters, it's also the pressure. Not just the mass, but the pressure. And the pressure gravitates, and the pressure is negative for the vacuum. Okay, so it turns out that you get repulsive gravity. So if you imagine Newton being embedded in a very dense vacuum, the apple will not fall, but rather fly up faster and faster, speed up away from Newton, because there will be repulsive gravity pushing the apple away from Newton. And this repulsive gravity is what's responsible for the speeding up of the expansion of the universe, because what happened was, early on, matter was most important, dominant, very dense. But then as the universe expanded, matter got diluted. At some point, it got diluted so much that it went below the vacuum mass density. Below, and at that point, the vacuum started dominating, and then you start to see the accelerated expansion, which happened when the universe was roughly half of its present age.
Is this what they refer to as like dark energy,
yes,
dark
that's
matter?
The dark.
And this is something that's, a big topic in science right now, right?
It's really embarrassing, I should say, because I'm a cosmologist. I study the universe, and we get paid even though we don't know what we're talking about. Right. I'll explain. So 1933, an astronomer in Caltech called Fritz Zwicky discovered dark matter. How did he discover? He looked at galaxies in a cluster, in a group of galaxies, and they move around. And he realized that if there was only the matter that we are familiar with, in the form of stars and gas, then it wouldn't bind those galaxies. They move so fast that they should move out of the cluster. And then he reasoned that there must be more matter to keep them bound. And he called it dark matter. Okay, that was 1933. For 40 years, this idea was completely sidelined by the mainstream of astronomy. Speaking about the mainstream being open to evidence, it's very easy to ignore it. So people
why did they ignore it? Just it was
why?
too
Because
weird.
We don't see dark matter in the solar system.
Yeah, it was too weird.
I mean, we think that what we see around us must represent the entire universe, okay? We don't see dark matter in the solar system because we are made of matter, that is ordinary. And I should say also, we thought that the sun is made of the same matter as the Earth. That was the prevailing thought until 1925, exactly a century ago, when a young scientist, she did her PhD, Cecilia Payne-Kapashkin, the first PhD in astronomy at Harvard University, was by Cecilia Payne-Kapashkin. She was at Radcliffe at the time and did it in collaboration between the Radcliffe and Harvard organizations. But and she discovered that the sun is made mostly of hydrogen, based on analyzing the light coming from the sun. And in her PhD defense, the most distinguished expert on stars at the time, highly respected, the director of the Princeton University Observatory, named Henry Norris Russell, dissuaded her from including this statement because he said, that is impossible. We know that the sun is made of the same material as the Earth. Therefore, she took it out.
Meaning what? Like, what does that mean, the same material of the Earth?
Meaning the Earth is mostly iron and heavy elements.
Just a planet.
Just like a planet.
Okay.
But he was wrong, because it took him 4 years to do his own studies and realize, and then he published a paper saying...
He stole her idea?
He basically said, yes, the sun is made mostly of hydrogen. Now...
Did he credit her?
Yeah, I think he mentioned her, but the strange thing is, I have a colleague from Harvard that was in a visiting committee at Princeton University a couple of decades ago, and the chair of the Department of Astrophysical Sciences at Princeton said that we have a long and distinguished tradition of astronomy at Princeton. For example, Henry Norris Russell discovered that the sun is made mostly of hydrogen. So my colleague corrected him and said, no, it was actually someone else.
Exactly.
And and so that was the first mistake about the composition of things. But then it turns out that most of the universe is made of stuff that we don't find at all in the solar system. And it's called dark matter. And only in the 70s, astronomers like Vera Rubin and others confirmed what Zwicky claimed all along, that there is dark matter making up 84% of the matter in the universe. So we are just a small minority representation of the mass budget of the universe, the matter that we are made of. We don't have a clue as to what dark matter is. It's just a label. And we don't know also what the vacuum is made of. That's dark energy. So the dark components are just a label of our ignorance.
Something we don't know.
We don't know, and we still get paid. That's the strange thing.
I like that. Yeah, I like that. That's a good job.
I mean, if I lose my job, I'll come and work for you.
There you go. We've always got a spot for you.
Okay.
So, by the way, so dark matter is very weird because matter, as we know, including hydrogen in the sun and matter here on Earth, you can see it.
Right.
So the dark matter doesn't interact with light at all.
Right.
And we don't know anything like that to have ever existed within our realm, have we?
The closest we got to it were particles that are really interacting very weakly with matter. They're called neutrinos, and they're produced by nuclear fusion. So, for example, the sun is a nuclear reactor. Just think about it. Nuclear reactor kept together by gravity. That's what the sun is. It's a fusion reactor. You take hydrogen atoms and smash them because the temperature is very high at the center, so they collide with each other, and every now and then they fuse to make helium, and that releases energy, but releases also neutrinos, and the neutrinos escape from the sun. We detected them. So even though they're very weakly interacting, we can detect them. So in principle, we know of particles that interact very weakly with matter, but dark matter is at the extreme because we haven't detected it at all. And we invested
a lot of mass.
A lot of mass passing through our body, presumably right now.
Yeah.
And, scientists invested $10 billion in the Large Hadron Collider, $10 billion in Europe, CERN, in search for one type of dark matter that was very popular. It was associated with supersymmetry, which is some new symmetry of nature. And for decades, when I started astrophysics, everyone was arguing it's very likely that the dark matter is made of the lightest particle that is associated with supersymmetry. It's called the lightest supersymmetric particle. And so they decided, let's fund a collider that smashes particles, and maybe this particle will pop up. And it was in the natural range of parameters, so they invested $10 billion. Now, of course, the Large Hadron Collider discovered the Higgs boson, and the Nobel Prize was given for that, but that was old news. What we really wanted to find is the dark matter. We haven't found it. So I say, look, we invested $10 billion. We didn't find the dark matter. Even if we were to find the lightest supersymmetric particle, it would have very little implications for humanity in the future, for the private lives of people. If we invest only 1% of that, let's say $100 million, in the search for extraterrestrial probes or equipment, it would change the future of humanity if we find something, and we haven't done it. So I say something is wrong in the way that, in the focus that we put on the search for dark matter relative to the search for probes, because both of them we have a lot of uncertainty about. And obviously the taxpayers, the public, really wants to know if we are alone. So it's not a waste of taxpayers' money, it's a reflection of taxpayers' money.
Right.
So I would argue that this should become part of the mainstream. The search for extraterrestrial intelligence should be the mainstream of astronomy. And of course, what my colleagues say, they say extraordinary claims require extraordinary evidence. I say extraordinary evidence requires extraordinary funding. If you don't put the money, you could have argued the lightest supersymmetric particle is an extraordinary claim and then put nothing towards that, and we would never know. But of course, to break the frontiers of science, you need to put money into it. And if you don't fund the search for equipment from other civilizations, you will never find it.
If you had unlimited check, what would you do? How would you?
Oh, that's the Galileo. I know exactly what to do.
Yeah.
Currently, I have a few $1 million. What I need is something at the level of $100 million to do a very thorough study, for example, of what the government calls unidentified aerial phenomena.
This is the thing that we've been reading about in the New York Times and declassifying. You hearing all about it stuff going on. We don't know what it is.
Yeah, so exactly a year ago, I was in a forum called the Ignatius Forum in the company of the Director of National Intelligence, Avril Haines. She received a bachelor's degree in theoretical physics. And I was chatting with her, in the green room, and I asked her, Avril, what is your gut feeling? What do you think these objects are that you don't identify? And she said, I don't know. And I frankly think that, the government is not a scientific organization.
Yeah, but she wouldn't tell you the truth if she did know, right? She'd be bad.
No, she would tell me the truth, and I trust her because she's a physicist in training.
But she'd be like, they're aliens.
Okay, well, so then we went on stage, okay?
Yeah.
There was also Bill Nelson, the head of NASA, and Jeff Bezos was there as well.
He's out of his element, right? He shouldn't be up there on stage with you.
Well, he was saying...
Like, he he ships shit. Like, why is he up there with you?
Well, he wants to ship it to space now.
Yeah, I'm just saying.
So he would ship, Amazon
rich,
will deliver to space, okay?
But if he wants to help you, I think we know how. $100 million.
Well, what he was saying is his ambition is to put like a huge, tens of billions of people in space. And then the Earth would be just like a national park. You come and visit it every now and then, but most people will be out there. And he said he was inspired for that by watching Star Trek as a kid. So I whispered to Avril, who was sitting next to me, and said, I never liked science fiction. It didn't make sense to me because it violates the laws of physics. And she said, Avi, we have to work on you. But then, she went on stage and she said, obviously these unidentified objects are a mixed bag. Some of them may be human-made and some may be natural, but, it may well be that a small number arrived extraterrestrially. She said that. And, to me, it just implies that these are intriguing reports that we should follow on, okay? Because obviously the government cares about it. So I established the Galileo Project to do that. And we now have a suite of instruments that takes a video of the sky in the infrared, in the radio, in the optical, and in audio. And we will use artificial intelligence to digest the data and tell us whether we are looking at a natural object like a bird or an insect, or whether we are looking at a human-made object like a weather balloon, a drone, an airplane, or a satellite, or something else. And, we should behave like kids. We shouldn't assume that we know the answer, like the experts always tell you. Because one of the biggest traumatic experience I had as a kid was coming to the dinner table, asking a difficult question, and then seeing the adults in the room dismissing the question because they didn't know the answer. And I thought that by becoming a scientist, I would figure out the answer myself. I don't need to pretend that I know more. We can just be guided by evidence. That's the way science is done. But unfortunately, it's really strange, but even within science, the practitioners want to maintain an image of an adult, the adult in the room, to pretend they know more than they actually know, and to avoid collecting evidence because that would be a reputation risk if it turns out that it violates what they said initially. Also, if it's something really new, it would imply that as experts, they did not anticipate it. So they would rather argue, Oumuamua must have been a rock of a type that we've never seen before because that's natural.
Keeps them the expert.
Keeps them as experts. Yeah. It's just that, it's a natural object from another type. There are different types of rocks, not a problem.
So as we've been going for an hour 25, so I want to move on to something everybody's interested in, which is black holes, right? Okay. One of the most fascinating and weird things probably in the universe. Albert Einstein, as he worked out his theory of relativity, as he kind of theoretically thought about the prediction of something like a black hole, he thought his theory must have a flaw because it was just so unbelievable. Why are black holes so unbelievable? Like, what is it that spooked Einstein to the point where he's like, this is impossible, this theory is wrong? Obviously, we've proven, and we've even observed them now, that they are real and they're out there. Right.
So the thing is that Einstein's theory of gravity predicts that it's basically says that it's incomplete, in the sense that a black hole, at the middle of the black hole, there is a singularity of space and time, meaning that if matter, just imagine a star collapsing, which actually happens for stars more massive than 8 times the mass of the sun. They usually consume their nuclear fuel and then collapse, okay? And if the star is more than, 15 times the mass of the sun, then it could end up in a black hole. The core of the star simply collapses to a point. And just think about it. It goes all the way to a point, and eventually you get a very extreme curvature of space and time. Einstein's innovation was to argue that space and time are not rigid. It's just like the surface of a trampoline. If you put a heavy ball in the middle of the trampoline, then it will curve the surface. And if you have a marble that you send on that curved surface, it could move in a circle around the center, even though if you were to take out the ball from the center, it would move in a straight line. So that is the analog of a planet like the Earth moving around the sun. Gravity is not a force, it's the curvature of space and time. So the Earth wants to move straight. So if you remove the sun, the Earth will continue straight, just like the marble on a flat surface. But because of the sun, like this ball that you put in the middle, the space is curved, space and time are curved such that the Earth moves around the sun. And that's what gravity is, according to Einstein. So, but in the extreme case, if you pull the surface of this trampoline too much, it tears apart somewhere. And that's the singularity of a black hole, okay? And that means the theory breaks down. And we know why it breaks down. It's because it's incomplete. It doesn't have quantum mechanics. So we know that once you get very close to the singularity, quantum mechanics matters. And we don't have a theory that unifies quantum mechanics and gravity. Einstein dedicated the last decade of his life trying to figure out a theory that unifies quantum mechanics and gravity. We are still trying to do that.
The theory of everything, they call it, right?
Yeah, it's not really everything. By the way, the reason it's not everything is, there is this tendency of physicists to say that we will reduce nature to some simple fundamental laws. But what they are missing is that complex systems, even if you have let's say the laws of chess, you would never appreciate just from the laws of chess how amazing a master is, because from the same laws of chess you can have different moves. And looking at complex systems that use the same fundamental laws of nature, understanding the laws is really a very small part of the puzzle. You want to understand complex systems, how they, like life. What is life? That will not come out of physicists understanding the theory of everything. You have to figure out what is intelligence, what is consciousness. These are questions about complex systems. By the way, I think consciousness is nothing special. It's just that the system is complex. And when we die, it's just like unplugging a computer from the wall. Basically the system shuts off, and in principle we could live forever if you just figure out how to repair this body so that it will not disappear. So eventually we might live for a very long time. I don't know if it's a blessing for everyone, but you will have a choice. So the point is that when you deal with complex systems, things are more interesting and beyond the fundamental laws. And I think in the future, that will be the focus of science. It's not the fundamental laws. Like physicists were very proud that they're leading the frontiers but that's not really the most challenging task that we have. It's to understand complex systems and replicate them, like in intelligence, consciousness, all these AI systems, they will become sentient. And then we will realize what sentience means, So anyway, coming back to what so we were talking about black holes, and black holes are they have these singularities where Einstein's theory breaks down.
Why does it break down at a singularity?
Because the curvature of space and time becomes infinite. So it's like a very extreme. By the way, I had the...
It makes no sense. Right?
Yeah.
For it to be infinite.
Well, it cannot be infinite. Something must correct it, and that's quantum mechanics. By the way...
why can't it be infinite?
Because eventually you reach curvature of the trampoline such that it will tear apart. So in the case of Einstein's theory, you reach a curvature of space and time such that quantum mechanics matters. Okay? You definitely have to include quantum mechanics at some scale. And that's what we are missing. But I should say, I had a flood in the basement of our home a few years ago, and I called the plumber that came over, and we found the tree roots in the sewer. Okay, I helped him to clean it up. And by the way, I enjoy the company of people that don't know much about science. I really love to speak with them. What?
Peasants.
Not peasants.
No, I'm just kidding.
Like me. I mean, I grew up on a farm,
Yeah.
So I completely relate. So anyway, I then thought to myself, I never thought that the water from my house goes somewhere. There is a reservoir of the town where it goes to, like through the sewer. Mm-hmm. And I never thought about it until it was clogged. So that led me to think, what happens in the middle of a black hole? Where does matter go?
It's going somewhere, right?
Somewhere.
Yeah.
And one possibility is that it's clogged. The singularity is clogged. And you build up an object with very high density, just like an extremely dense star in the middle of a black hole. Mm-hmm. That's one possibility.
It's just a big star, but it's too heavy.
It's extremely dense, but you can't see it because it's hidden behind this event horizon. You can't see through it. But if you wanted to see what's there, you can jump into a black hole. And I recommend to many of my colleagues who study string theory, if they want to test their theory, they should get into one of the nearby black holes. Mm-hmm. And they say that I have an ulterior motive to send them there.
Yeah. So, but I guess it's going somewhere, but it's not, because the mass doesn't disappear. It stays there, or it radiates away, I guess,
so there are
slowly.
Two possibilities. Either you collect the mass in some extremely dense object, the highest density possible. It's called the Planck density, where quantum mechanics matter. You can have a Planck density object, extremely dense, sitting there and collecting everything that falls. Another possibility is that it goes somewhere else, like another universe or somewhere. We don't know.
But the mass does stay there. So is it possible that it goes somewhere else, but also it holds the mass there?
No, it needs to be there.
Yeah.
By the way, Stephen Hawking, we mentioned him before, he realized that black holes eventually evaporate.
Right. Hawking's radiation.
Hawking radiation. Yeah. And by the way, he discovered it because there was a young student at Princeton named Jacob Bekenstein, who suggested that black holes, based on what Hawking derived earlier, that when two black holes merge, the area always increases. That's what Hawking showed. And so Bekenstein said, well, maybe it means that they have entropy. They have some information on their surface, and according to thermodynamics, entropy always increases, and so the area of a black hole always increases because it has some entropy on it. And Hawking said that makes no sense whatsoever. Who is this student saying that? Mm-hmm. Just like in the case of Cecilia Payne-Koposchkin. And his goal was to prove him wrong. Mm-hmm. And he did a calculation, realized, he was right, Bekenstein. And in fact, black holes have entropy, they have a surface temperature, and that means they radiate. And that means they evaporate. So he wrote a paper about it. That was his most important result.
Right.
Just like in the case of the sun, with Henry Norris Russell. So, what I say is never dissuade a brilliant graduate student. Or if you don't believe what the student's saying, try to prove the student wrong, and you might find the most important result of your life.
How is it possible that it can radiate energy or mass away when light, which is pure energy, right, can't escape it?
It's very simple.
Yeah.
The black hole, as I mentioned, has an event horizon, right? So there is a size to the prism.
Right.
So imagine a prism that has some size, okay? Obviously, if you want to put a person in the prism, the person has to be smaller than the size of the prism, right? You can't push a person into a small cavity that, is too small, okay? So now, light is made of particles. They're called photons. And the wavelength of a photon, which is basically, a photon is just an electromagnetic wave that has a certain periodicity over some distance. The wavelength represents how compact is the region that you can localize a photon. You can't put a photon in a region that is smaller than its wavelength. That's the minimum size of a photon, a particle of light. So now imagine a photon, a particle of light, that has a wavelength bigger than the black hole. You can't keep it in the prism, okay? So the black hole would lose this photon. That's the Hawking radiation.
I see.
So it keeps losing particles because they're bigger. They have a wavelength comparable or bigger than the size
And
of
it's very, very slow, right?
It's very slow because these for astrophysical black holes, they are quite big. So these wavelengths are very long, and that means the particles carry very little energy, and therefore the evaporation is very slow. But if you made the black hole very small, then it would explode quickly.
Oh, it would explode.
Yeah.
Is it possible, it seems like the black hole is such a attractive place for imagination. I mean, what goes on in the center, you think about the Big Bang. Is the Big Bang a singularity or a black hole?
So that's another singularity, I should say. So Einstein theory breaks down in two places. Black holes, that's one singularity, when a star collapses to a singularity. Another is the Big Bang. We know that the density was infinite of matter there.
So it's like the center of a black hole.
Yeah. So then the question is, what was before the Big Bang? And we don't know the answer because we don't have a theory that unifies quantum mechanics and gravity.
It is possible that we are all in the center of a black hole.
Well, the singularity of a black hole is different. There are similarities.
How do you know it's different? I'm just curious.
Because when you make a black hole, there is a finite region of space that from where you gather the matter that ends up in the singularity. Whereas in the Big Bang case, it's actually an expanding situation that you start from the singularity and you're expanding out. And it's a singularity in time, not in space, because there was a point in time when the density was infinite and then...
Oh, actually, I want to ask you about a theory I just recalled. So we're talking about heat death and about the origin of the universe. Is it possible that, like, in unfathomable, trillions, hundreds of trillions of years, so there's a total heat death in the universe. There's like nothing left, basically. So one thing I heard that was really interesting is that in the ultimate heat death, the fact that basically there's nothing left turns it almost back into in a weird way, a singularity again, where because like the space basically disappears, it becomes homogeneous. It's like one uniform space.
Yeah.
Is it possible that in a weird way that is able to once again become a singularity as space becomes irrelevant almost?
No, I mean, it's not. I mean, think of it as a death of a person, so it is a simple state, but it's not the same as the initial state. And as I said before, we don't really know the future, in the distant future, because perhaps we are wrong about how the vacuum will behave. We don't know what the dark energy is. And maybe it will decay or something will happen to it and the universe will stop speeding up its expansion. And maybe after that it will contract. So there are suggestions that maybe the universe is cyclic. It's just going through cycles. We have to live that long to figure out what happens. For now, I mean, I should say there is another fashion in the study of the universe, and that's called the multiverse, to think that, in fact, there is much more outside the region that we can see. So there are other regions like our universe, but they have conditions very different than we have. And in fact, anything that can happen will happen an infinite number of times. So if a kid gets a bad grade in an exam, let's say gets a C, the kid shouldn't feel bad about it because there are many other regions of space and time where the kid gets a good grade.
There you go.
But I think of this as just like living in the metaverse. You can never test it. Therefore, it's not really science. It's sort of like a mental drug. I mean, so humans are attracted to imagined realities. They're attracted to those realities that flatter them. I'm not. I want to know, I want to see the pimples on the face of reality. I don't want it to look beautiful because I want to figure it out. That's what I want. And, even if it doesn't flatter me, I want to know what it is. To me, that's the meaning of true love. If you are in love with a person, the meaning of love is not to idealize the person as perfect. The meaning of real love is to notice the faults of the person and to nevertheless love that particular unique thing. And you can feel the same way about reality. You don't want to idealize reality, to make it the way that would flatter you the most, or that you would imagine it, like science fiction would imagine it. You want to know what it is, and then you will have a better connection to it. So, and another thing is, a lot of scientists in theoretical physics, they prefer to do mathematical gymnastics to demonstrate that they are smart. And I say, doing physics is not about showing that you are smart. Because, for example, if we discover aliens, extraterrestrials, you may not need mathematical sophistication to understand that. Nevertheless, it would be the most fundamental realization that humanity ever made if there is another civilization. So showing off by mathematical virtuosity, is not really the goal. We want to know what reality is like. And that could mean just looking up and seeing something, a probe, rather than doing string theory, which shows that you are really smart, you can do manipulations, but we don't know if there are extra dimensions. And people worked on that for half a century. We don't have a shred of evidence that extra dimensions exist.
String theory is the attempt to kind of marry
quantum mechanics and gravity. So that's one of the attempts to do exactly what Einstein failed to do. But it's perfectly legitimate and appropriate to do that. But we should also seek guidance from experiments, and because that's what physics is about. You can think of it as a relationship of love, in which you compare a situation with platonic love, where you just idealize your partner without any physical contact. That's not physics, just imagining things about your partner. The physical interaction makes love worthwhile and meaningful. And that's what physics is about. Through experiments, let's learn about the world. It's not about us showing off with mathematical equations and so forth. It's about us figuring out the partner that we have, which is reality.
I see. So I got you. You'd rather focus on math than theoretical or whatever.
I would focus on
mind
experiment, on evidence.
Yeah, really. Yeah. So one thing I wanted to go back to the black holes. It turns out that, I think this is a relatively recent discovery, that there are super massive black holes at the center of most galaxies, right? True. So it turns out that they're not just some weird cosmic coincidence, but actually seems to be fundamental, like in the most fundamental way, a part of how our universe and galaxies are able to exist.
Yeah, so a galaxy like the Milky Way started with a cloud of gas, okay, that condensed. And some of the gas ended up at the center and made a black hole. So that's really natural. When you do computer simulations of the formation of galaxies, you end up with some gas at the center. And what happens is you make a baby black hole, and the baby gets fed, sort of like a baby sitting at the dinner table, gets fed with gas. And at some point, the baby becomes so energetic after eating enough gas in the center of a galaxy that it shoves the food off the table. And we see that because we see the environment of a black hole brightening up. It's called a quasar. So you get a very bright emission of light and outflows of material coming from the center of a galaxy. At that point, the black hole is removing the gas that feeds it. So it's like a baby shoving off the food from the dinner table. And at that point, the feeding stops. So black holes grow up to about a fraction of a percent of the amount of gas around them, because after a while, they just throw the food off the table. And we see that. And every galaxy has a black hole at its center. In fact, just a week ago, we published a paper with my postdoc. We know the Milky Way has a black hole that weighs 4 million times the mass of the sun at the center.
That would be considered a supermassive
black hole. And the Nobel Prize for in 2020 was given for that to two people that realized that stars very close to it are moving really fast at thousands of kilometers per second and indicate that there is a dark object in the middle, a black hole, and so they got the Nobel Prize. That's Andrea Ghez and Reinhard Genz. Actually, Andrea lives here in Los Angeles. And it turns out what we discovered last week is there is a small galaxy, a dwarf galaxy, 1,000 times less massive than the Milky Way. In the outskirts of the Milky Way, it's sort of like a satellite moving far away, and it has a black hole roughly of the same mass as the Milky Way.
Interesting.
3 million solar masses. And we calculated how much light should be emitted from that black hole. And guess what? We looked through telescopes in X-rays, in radio, and we found evidence for it. So it's really exciting that there is this tiny galaxy that developed a black hole similar to the Milky Way.
What does that mean? That the black hole just consumed more mass there in the galaxy?
No,
no.
What I think is most likely is that the galaxy was bigger. This dwarf galaxy was bigger to start with, but then it passed close to the center of the Milky Way as it was moving around it, and the outer envelope of this galaxy was removed by the tidal
So
force.
where did it go? It stayed with the Milky Way?
Yeah, stayed with it. So it lost a lot of its mass. That's my guess.
Oh, so I see. That makes sense.
And then you were left with a very massive black hole at the center of its small dwarf galaxy.
Right.
That would be my guess, but we still have to figure it out. That's the next paper that we will work on.
And when you look at like galaxies, they're rotating.
Right.
Like planetary systems. Is that due to the mass of the black hole?
No, most of the mass, so the black hole is just a fraction of a percent. So it dominates very close to the center at a distance that is about 1,000 times less than the size of the galaxy. Very small distance. But farther out, it's mostly the stars, and then eventually it's the dark matter. So the dark matter is creating a halo that extends 10 times farther than the luminous core of a galaxy where the stars are. These are called dark matter halos. So the Milky Way has a lot of mass in the outskirts that are simply dark matter. And the central core of the galaxy is mostly stars and gas. And then at the very center, it's the black hole that dominates.
So it's not like a planetary system. It's not rotating around the black hole. It's just a result of a forming galaxy that there's a bunch of mass in the center.
Yeah, so what happened initially, the dark matter and the gas, the dark matter and the ordinary matter are mixed up and they make the galaxy, but then the ordinary matter can cool because it emits light. So it cools and condenses to the inner region. Whereas the dark matter cannot emit light.
So why does it rotate?
Oh, it's rotating because it started with a little bit of rotation because there are nearby galaxies that gave it a torque. And so there was a little bit of rotation at about 5% rotation relative to random motions. And then when the gas condenses, the rotation is amplified because it's a conservation of angular momentum, it's called. Basically, you start with small rotation, but when you go, just like a skater, when a skater puts arms out and spins, it rotates at a certain rate, but then
just
when
on a massive scale.
When the skater puts the hands closer to the body, it spins. The body spins much faster, right? You see that in skate competition.
Yeah.
So that's the same thing. When the gas of the galaxy came to the inner part, it started spinning much more rapidly, and then the rotation created this disk of stars that we see as the Milky Way.
Is it possible to travel between galaxies?
Yeah.
You think so? Because what is between galaxies, right? It's just
there is a little bit of gas left over and some dark matter left over. Not everything was consumed in galaxies. So there is some material there. But, the amazing thing is that every now and then galaxies collide. We will collide with the Andromeda galaxy, our sister galaxy nearby, in about a few billion years. Okay, we will collide because it's coming towards us, and eventually it will be looming over the horizon. So the night sky will change completely once we collide with Andromeda. It's a sister galaxy similar to ours. And galaxies collide, so the two black holes at the centers come together and make a pair and eventually merge. Okay? So when the two black holes come together, they can act like a slingshot. they can eject stars up to the speed of light. We calculated it in a paper like about 6 years ago with a postdoc of mine, and we showed that there is a population of stars in the universe that move close to the speed of light because they were ejected from these black hole binaries.
They're rogue stars in between galaxies?
Yeah.
Oh, wow, that's interesting.
And just think about being on a planet around such a star. You know, I think travel agencies, interstellar travel agencies, would make the most profit on that because they can sell tickets to a trip starting at the center of a galaxy, going through the galaxy into the universe, moving close to the speed of light. The other advantage is that you will age more slowly than your friends that are left in the galaxy because you are moving close to the speed of light. So, you know, it's an amazing trip.
It's theoretical that you could have a solar system that's sustaining life.
Yeah.
And it's in between galaxies, just out there on its own.
Around such a star that moves close to the speed of light, definitely. So we wrote the first paper saying that. And, you know, if I were to establish a business that is interstellar, that would be, I would sell tickets to such a ride.
Interesting.
You know? When Andromeda and the Milky Way will collide, that would be an amazing...
It's going to be a beautiful night sky as it gets closer to our galaxy.
I mean, the Milky Way is called the Milky Way because you are looking at a disk of stars edge on, because we are part of it. But eventually, when the two disks will collide, they will become a football-shaped galaxy called an elliptical galaxy. It will be spread all over the sky, and you know, things will look different.
We have very little time. I'm just going to shoot some questions at you.
Go ahead.
What do you think is the greatest risk to human extinction from space, like, you know, excluding nuclear war and all that stuff?
Well, it's an asteroid hitting Earth. We know that dinosaurs went extinct 66 million years ago. They had huge bodies. They were very proud. They dominated everything on Earth. But their brain was
They're idiots.
Yeah, they were idiots. You know, they didn't develop telescopes that would warn them. They were not aware of that risk. So there is a big lesson to be learned from that don't bully the nerds in your class.
They're going to save everybody.
Because, they could save everybody.
But so are you encouraged by NASA just had this hugely successful DART mission where they sent out a probe, or I don't know, what do you call it? It's a little space craft, and they're able to change the directional path of an asteroid.
Yeah,
Is that how you think
I think there are more elegant ways of doing it. Like, for example, you can shoot a laser that would vaporize part of the asteroid such that it will push it away. You just need to nudge it a little bit.
We have lasers that strong, you think?
Yeah, we can develop that.
So why aren't they doing that instead of this whole DART thing?
Well, colliding is sort of the Bruce Willis approach, right? But so a lot of people relate. I mean, a lot of alpha males like that.
Yes.
But another way is to paint one side of the asteroid. Just spray paint it such that it will reflect sunlight differently. And if you see it far enough and you give it a small nudge, it would miss the Earth.
Interesting. So, are you confident that we will be able to avoid that? That kind of, it's almost inevitable, right? If you don't learn to stop it and to detect it, it's going to happen again.
Yeah,
do you think we're going to be able to avoid that?
Yeah, but I still recommend that we produce copies of what we have on Earth and put them on the moon, put them on Mars. So I'm in favor. You know, I bought a new laptop just a few months ago, and I had a recovery and backup system that I bought with it for a very low price. And it was a small device that you connect to the laptop that keeps memory of everything on it. So I think we should store everything we care about on Earth. We should store it at a recovery and backup system on the moon. And so that the people that are on the moon with the Artemis program of NASA will be able to reconstruct the most important. So we can put all the human creations, all the films, all the books, all the music that was produced by humans, plus all the DNA, all the genetic information about all life forms on Earth, you can store it on the cloud, on the moon, such that if something bad, a catastrophe happens on Earth, perhaps the scientists over there would be able to reconstruct it. And, the more copies we make, the less likely it is that we will wipe everything that is precious to us.
You think we're going to make it like we're gonna make it all the way, or what's the chance we're gonna like colonate another star or become multiplanetary here in our own solar system? Are we going to avoid the Great Firewall, as they call it, right?
Yeah.
To intelligence.
That's an excellent question, and I think we will not be admitted to the club of intelligent civilizations if we don't get our act together, which may well happen because you see, the risk of a nuclear war in Ukraine. You see the lack of attention to climate change and the fact that information was not shared by the Chinese government with the rest of the world about COVID-19 when it was evident that it happened in the Wuhan province. And so it's not clear that humans are cooperating in a way that would prevent an existential catastrophe. And that's why I think that it's really up to us and up to the people we elect to lead us. And it can go either way. I don't know. It really depends on us. And I very much hope that we will be smart enough to... Now, my wife, I was asked many times for example, by the Boston Globe a decade ago, what will happen if a spacecraft landed in your backyard? Would you go in it? And I said, yes, definitely, I'll go in it. But my wife said, well, you can go if you want, but just make sure that you leave the car keys with me and ask them not to ruin the loan when they lift off. Now, I was asked again the same question a few weeks ago. And I asked my wife again. And she said, well, now I think that I will just ask you to turn off the lights and I'll join you. Because it looks like the world is not going in the right direction. And so, there is this worry that we might not be heading, even though there is no sort of Cold War with Russia in the way that it used to exist with nuclear threat. It seems like there are lots of existential risks that are popping up. And
right.
I mean, I don't have a clear answer. It depends on what we do.
Yeah. I forget what is this paradox called, or Occam's razor or something that says no, it's not that, but it says the reason we don't see so much.
Oh no,
life,
that's Fermi's paradox.
Yeah, Fermi is because there's these great firewalls that test.
That's possible.
Smart civilization.
I think that the reason we didn't see is because we didn't look.
We're not looking yet. Yeah.
Yes.
Yeah.
So if we start searching for packages in our mailbox, we might find them.
There it is. Avi Loeb. We ran out of time, unfortunately. You have a flight to catch, but I thank you so much for being here. Your books you just came out, what was the name of your new book?
Extraterrestrial, a year and a half ago, and there is a new one coming up in June 2023. It will be called Interstellar.
Nice. What's the focus of that one?
On the future of humanity. So exactly what we talked at the end. How can we make our future better? And how would the future be shaped by us meeting extraterrestrials?
Favorite sci-fi movie? Is it Contact?
No.
No.
Arrival.
Wait, that's the one that recently came out, right? With the
a few years ago.
Yeah, that was nice. That was a good one.
Actually it turns out that the producer of that film is working with me now.
Oh yeah?
Yeah.
What, on a new one? Are you consulting?
On something based on my book.
You can't talk about it probably.
Well, we already are working on it, but it's related to my book Extraterrestrial.
Fun, exciting. Congratulations. That's awesome.
Thank you.
Yeah, what I liked about this movie was the depiction of the alien life, right? It was so different, and it was all about trying to figure out how to communicate.
Yeah, it's the communication, which is a very important question. How do we figure out what they mean, and I found this film amazing.
Cool, nice. All right, we're running out of time here, so I'm going to let you run. Avi, thank you so much for taking the time to come out here. It was a great conversation, and thank you very much.
My pleasure.
All right.
Thanks for hosting me.
See you guys on Monday. We'll be back to our usual shtick. Next week, we'll be doing our live shows and everything. We don't have guests next week, do we, Dan?
Not next week.
Yeah, so there
Actually,
you go.
we should maybe clarify. You had misspoke on the last episode about Howie being next week. It's not next week, it's the following week.
Okay. Anyway, guys, have a great weekend. We'll see you on Monday. Take care, everybody. Bye.